Hi everyone, my name is Rangan Mukherjee and today I am going to share with you a coding problem that I have solved recently. Uh, so there are two aspects for posting this video. First of all, to improve my English speaking skill, and secondly, of course, my coding ability, to improve my coding ability. So the question that I have solved today is called search in a rotated sorted array. I have used Java to solve this question, and this question is mostly based on binary search. So let's see what is the question. So let me give you the overview of this question uh, at the beginning. So suppose you have a array 1 2 3 4 5 6. So this is the array that you have, and as we all know that to perform binary search in a particular array where you have to find any element, the array must be sorted. So in this case, in rotated sorted array, so first of all, what is a rotated sorted array? So if if we want to make this array a rotated sorted array, then what we will do is we will move these numbers. Suppose 1 2 3 4 5 6, these are the numbers. We will move this number, I mean move in such a way that it will seem like that we have done some kind of rotation, right? So suppose we will move 6 over here, then we will move 5 over here, then we will move 4 over here, and so the new array will be like this. 5, 6, 1, 2, 3. So here you can see that the array is actually sorted, but it is rotated. So this is a rotated sorted array. So we have to search an element uh, from a rotated sorted array, but the catch is that we have to maintain a time complexity of log n. Here in LeetCode, the time complexity is fixed, that is big of log n, here as it is mentioned clearly. I am giving you a bit time so that you can pause the video and go through the question. Yes, big of log n, which is the case over here. So I hope you have seen the question. Now the challenge over here is to solve the question in big of log n time complexity. Um, if the time complexity was not mentioned in the question, then this question would have been a piece of cake, because you could have just applied linear search and you could have easily find out the solution to this problem, because you could have just used a loop and you could have gone through the total array, and whatever the element which is told to find, you could have find it easily. But here the catch is that it is told that you have to solve this question with big of log n time complexity. So this is a challenge. So let's find some ways. I mean, let's tell you my thought process, how I thought, or what kind of thinking I did to solve this question. So let's go. So let us see one thing. I guess you all have noticed one thing, that even after the rotation, the array is actually sorted, but it is sorted in a different manner. So if you see this portion of the array 1 2 3, it is sorted. Again, if you see this half of the array 4 5 6, this half is also sorted. So the after rotation, the array is actually divided into two array, the array is actually divided into two sorted array. So what whatever my basic approach to solve this question is like apply a function, then pass this subarray first. I mean, pass this subarray first, the 4, 5, 6 subarray, and then again pass the 1, 2, 3 subarray. In whichever subarray there is the answer, you will find it. I mean, like, you will get the answer, and if you don't get the answer, then return -1. If none of the subarray consist of the answer, then both of the function will return -1. I mean, not both the function, but both subarrays, I mean, will pass this subarray as an argument. So in both the cases, it will return -1. So my basic approach was this, to divide this single array into two different arrays, then pass it to a function, and then find out the answer. But even then, you have to find the position from where the two array can be divided. Suppose in this case the 1, wait just a second, here in this case the 1, here you have to find this position to divide the two array. Until and unless you find out from which position you can divide two arrays, you cannot solve this question. So to find out from which position you can divide the array, you can just find the smallest element in an array. Wherever you will find the smallest element in an array, from that to the very last. Suppose here in this position you have found out the smallest element, which is 1. So 1, 2, 3, you can consider 1, 2, 3 to be an array, and 4, 5, 6 to be another array. So the position of the smallest element is very important over here. To find out the position of the smallest element, this is the most important part over here. So generally, if we have to find any kind of smallest element, so we generally apply the big of n time complexity. We just compare with we just take one number as a reference and compare it with the other numbers, and if we find it the other number is smaller than the actual reference number, then we replace the number, right? So that process is good, but it will take big of n time complexity, right? That process will take big of n time complexity. So the overall time complexity will become big of n plus log n. So here n is the dominant factor, so the time complexity becomes big of n. But we are told that we have to solve this question with big of log n time complexity. So we cannot follow that rule to find out the smallest element like that. Instead, we have to apply binary search only over here to find out the smallest element. Now to find this now to find the smallest element of the array in big of log n time complexity, we will use a modified version of binary search, with the help of which we can find the smallest element in an array. So smallest element in a rotated sorted array. So I have already done this problem and I have written this algorithm separately. So what we will do is we will run and debug this algorithm to see how it is working. So let's go. So initially we can see that the s is equal to s, that is the start, is 0 and end is 7, which is the length minus 1 value. So let's go. First we can see this is the array, and as we can see s is equal to 0 and e is equal to 7. Let's go to the next step. Now in this step we are checking if the error mid is greater than equal to error 0. Here the error mid is of course 0 plus 7 by 2, which is 3. So here we can clearly see the index 3 is greater than or equal, greater than index 0. So we will get inside this if else conditional statement, then we will do mid plus 1, which will make the index of start to be 4 and the index of end will remain same. Then again we will calculate the mid. So now in this case the mid will be 7 plus 4, 8, 9, 10, 11 by 2, that is mostly 6. So here the mid will be, like 5. So moving on. Again we will see that the loop repeats itself. It will check that condition again, but that condition will not satisfy this time. So this will directly go to the else condition, and we will provide e is equal to mid. That means we will change the value of e to be the current mid, so the value of e will become 5 now. Here you can see. Then again we will calculate the mid. So start is 4, end is 5. That is, so the mid value will be now it will be 4, and yes, we will eventually get the s to be 5 in this manner. And we will get the s over here. So in this way we find the smallest element in a rotated sorted array. So we can divide one single array into two different arrays. Now as we get the s value, so what we will do, we will call the function. That we have written over here. Here I have named my function to be find L, and I have passed the parameters of one array, one start variable, one end, and the target variable, which we are trying to find. So first what I have done over here is I have called the function. I have made it a static function so that I can easily call it within my class. So first I have given the range of, first I have passed the array which is nums over here, and then I have given the range from s to nums dot length minus 1, that is the end of the array, and I have passed the value of target. and for the second portion I have given the range to be 0 from before s, just one value before s, one index before s, that is 0 to s minus 1 and target. And then what I have done is I have stored these values in two variables, that is answer 1 and answer 2. So if I get minus 1 in any of these two variables, that means that in that portion of that array the element does not exist. And if I get minus 1 in both the variables, then the element that is given as a target is non-existent, that is, that element does not exist in that particular array. So basically here we are given 3 test cases where the first target was 0, and as we can see the 0 is already existing in this array. So we have divided this array in two parts, that is, one is 0 1 2 and other is 4 5 6 7. So of course the 0 1 2 portion consists the 0, so it gave the answer 0 and it gave the appropriate answer 4. Now in case of case 2, the target was 3. The target was 3, which was non-existent in that particular array. So even after dividing the array in two portions, that is 0 1 2 and 4 5 6 7, we couldn't find the element. So in both cases of calling the function, we have returned -1, so the output is -1 over here. And in case 3, which consists only a single element 1, and here the target is 0, so similarly the target is non-existent in the array, so here we don't have to divide anything, so here automatically the output becomes 1. So yeah, in this way I have solved this problem. That's all. Although I have messed up in few places because I am not very sure about this algorithm, because I searched it in the internet, that is how to get log n time complexity to find the least element in an array, in a rotated sorted array. Then I got this, then I did some debugging stuff, and then I understand a bit, but I am not very clear about this concept, but it worked anyway, so that's all right. If any one of you have any better suggestion, then please comment below, and thank you for watching. Okay.